Okay, hello everyone. This is the exercise that I gave you. So this is actually showing you a beam AD. Okay? In this figure, it has a frictionless pin in A and a roller support in D. Okay? So this is A and D. So to start this problem, we could design or draw the free body diagram. So let me just draw the beam. Show that. Okay, that's the beam. So this is A, this is D. Okay, now we have a distribution load. Okay, and as I mentioned in class, this will have a certain shape. Okay, sometimes it's a rectangle, sometimes it's a triangle. So we are using those shapes to find the resultant of the force. Okay, so if we have here, so we are going to take the area of the triangle, which is a base and height. So half base and height is our weight or our force. Okay? Um, so we could take the distance also will be 1/3. So this will be 1/3 of the total. So if this is um, 2L/3, right? This is 2L/3, the distance. So we are going to take 1/3. Okay, 1/3. So we need to take 1/3 off 2/3. So this will be um, maybe around here. Maybe around here. That will be the half 2/3L and then V0. So that's our. I think we can make a triangle out. Let me read red color. Okay, let's say that's the and the triangle. This is B. Okay, this is B. This is C. And the weight maybe here. And the resultant is here, which is the um, V0L/3, right? Here from this part. Okay. And then we mention all the length here. This will be L/3, right? So the total is, so let me solve this. So this is 2/9L. So this is 2/9. And we can maybe change this to, this is also equal, if you multiply with 3/3, this is equal to 6/9. Okay. So if this is 2/9, then this will be 4/9. So let me write that as 4/9 here. That goes through. This is 4/9L. Okay. Okay, next. Because the question is asking the reaction at A and D, so we need to write the reaction. Okay. So this will be the reaction AX. We can write AX. We can write AY right there. And there will be no dx. This is just having the dy because it's a roller. It's a roller. And then what else do we need? The total. The total is L, so this will be 5 over 9, of course, right? The total length is L, so this is 5 over 9 L. Okay. And then this will be L over 3. Okay, what else do we have? Yeah, this is also L over 3. Okay, I think that's all, right? And then we could start with the sigma f x equals 0, sigma f y equals 0, sigma moment equal to 0. Okay, for this axial, for the axis, for x-axis, I think no force, right? No external force. So we could say that ax is 0, right? And then for the y-axis, we see that the ay so sigma fy equals 0. This is equal to ay plus dy equal this, right? And we need to find ay and dy, okay? That's the question, actually. So we could take the equilibrium of beam AD. Okay. So let's take the sigma moment. So if we take this beam, okay, we could take sigma moment at D or sigma moment at A. So let's try both to find the AY and DY. Okay. So the first question is asking the reaction at A and D, and the second question is the internal force. Okay, so let's say we are going to first is take D, okay, at D. So at D, there will be AY will couple, okay, and then make sure that we could deal with the uh, counterclockwise and clockwise. So let's say the counterclockwise is positive. So AY multiply with L, and this will be minus. Well, actually, okay, I forgot to mention in class that the assumptions you make, like this part here, how the moment will be rotate, going to the clockwise or counterclockwise, positive or negative, it doesn't matter. As long as you consistent to your assumptions, you will get your numbers correct. Okay? But I'm usually taking the counterclockwise positive. You can also take the clockwise positive, and you will get a similar result because the process in the middle, when you calculate the number, you will have it's the same principle. Okay, and you will get the correct result as long as you are consistent. Okay, okay, so let's take this as minus ay multiplied by L, and then the other part is positive, multiply with 5 over 9L, right? It's equal to 0. So ay L is this is 5 over 27, okay? And ay, so ay, we can write ay is 5 over 27. Okay. So first, that's our ay. So this is for this first case. Still the first, we need to take the sigma moment at A equal to 0. And again, my assumption is taking the counterclockwise as a positive. So at A, we have dy, that is minus dy, right? Minus dyl. And then, oh, it's positive, sorry. It's positive. And then minus 4/9l, right? So dy l is, or we could cancel out l directly and we say that this will be equal 4/27 WOL. Okay, so we get this. Okay. So the first question answered, okay. The reaction of A and D. The second one is the internal resultants, okay, on the cross section at B. Okay. So let me copy all this, okay, and we go to the next page. Okay, now let's open up, let's slice open B. So let's slice open B. Okay. So we could take B, slice open B. Okay. This is A, this is B, and then let's say this is AX, right? This is AY, and then this is, we have another triangle, right? If we take closely, if we take here, now we have the same principle of half, base, and height. Now the height is still the same, so half WO. Now the distance is L/3, which equal to over 6, right? Is this correct? Yeah, I think it should be correct, right? L/3, half base height, and then the distance should be 1/3. So the D is L/3, it should be 1/9L. Okay, 1/9L. So this will be the distance, maybe here. This is L/9, and this will be 2L/9. Oh, 8/9, sorry. 8/9. Okay. And then we take, this is the F or N, this is the shear and the moment. Okay. And again, we we are going to take the same thing. So here is the resultant. Resultant is over 6. This will be 8 over 9. This will be L over 9. Okay. Let me change the color. Okay. Now take the same tools. So F or N and B plus AX is equal 0. So NB is 0 because AX is 0, right? So no normal stress on no resultant stress in the B for the x-axis, and then sigma Fy equal to 0, Ay minus Ay is, what is Ay? Ay is here, 5 over 22nd. Let me write here. So Ax is 0. Oh, already written. So Ay is, and Dy is, so Ay, so the shear stress. Okay, let's take some calculation. Okay, so 6 multiply with um, just 27. Okay, right. This will be 30 minus 27 or 352. Okay, and then sigma moment at B. Okay. Let's say this is positive on the counterclockwise. Okay, this will be equal to 0. So minus Ay L over 3, and then plus this multiply with L over 9. Okay. And then plus MB equal to 0. So this will be what? 5 over 81 L squared, right? L squared. And then plus Okay, what else? We can, I think, compute. Uh, we can compute with 81. So 5 plus 1.5. Okay, so MB is negative 802. Okay, that's the answer. So this will be the moment at B. And since it's negative, so we had the wrong guess here. So this will be, should be going over there. So the moment should be going over there. That's the N, that's the B. Okay. Okay, that's it. Okay, just to notice that I make a small mistake here. This should be 2 over 9. But it doesn't really necessarily affected our calculation. So it's still the same results, but the different distance here. Okay, I write 8 over 9 because I thought it was L, but I remember this is L over 3. Okay, okay, but the result should be the same.